Good evening, everyone. In this video, we are going to learn the ray diagrams, about the ray diagrams using the lens. Okay, so I'll explain you in a very easy way, comparing with mirrors and lens. So these are the ray diagrams which will be asked from light chapter, which are very simple and very important as well for the board exams, right? Okay, good. Now let us learn about the ray diagrams for lenses. Okay, so we have different types of lenses. So we will study about two lenses. Okay, there are different types of lenses are given: convex lens, biconcave lens, plano-convex, plano-concave, concavo-convexo lens. So different types of lenses are there. So we will study about two types of lenses. Okay, one is convex lens, and the second one is concave lens. Okay, we can also call it as a biconvex lens or biconcave lens. Okay, so these are the two types of lenses. I'll draw the diagram of biconvex lens. Biconvex lens looks like this shape. Okay, the shape looks like, okay, in this way. This is called biconvex. Why are we calling it as a bi? Bi means two. If you observe here carefully, here the two sides, this side and the another side is bulged outside. Such type of lenses are known as biconvex lens. Okay, again, bi means again two sides. Bi means two. So here in this case, in biconcave lens, we observe that the two sides are bulged inside. This is known as biconcave lens. Okay, these are the diagrams. Okay, if we can represent them with the structure also, it looks like this is the structure. The lens, this is also biconvex lens. This is just a representation of the lens. This is the biconvex lens. Both are same. This structure, a symbol which we can use to represent biconvex lens. You can use even this structure or this structure to draw the ray diagrams in exam if it is asked. Okay, and the structure of biconcave lens is the symbol how we represent the bi. Here two arrows up and reverse, and one straight line. Here one straight line and upward Y, and you can see the bench symbol, right? Bench car symbol. So that way. So these are the representation of biconvex lens and biconcave lens. Okay, so as we have already seen, we have learnt in mirrors that there are conditions. We get 6 types of ray diagrams for concave mirrors, right? In mirrors, we have 6 types of rules, or 6 types of different image formations and 6 types of different conditions in mirrors. But here, in this case, see here, that is a concave mirror. Okay, it's called a concave mirror. That was a concave mirror, but here, in this case, convex lens. So we get the rule or different conditions for convex lens. So concave mirror is same, and convex lens is same. So ray diagrams rules are same. So there we study about mirror. Here it is concave mirror, convex lens. Okay, convex mirror, concave lens. Okay, don't get confused. Very simple. I'll explain in a very simple way. As I have already explained in the mirrors, okay, I'll draw the both the diagrams simultaneously. So here biconvex lens and concave mirror. You can compare these two so that you can understand easily. Okay, concave mirror, okay, and convex lens. Okay, what is the first condition? What is the first condition I have given you? I told you that you should follow one sequence or in a one order while drawing the diagram or while learning the table also. So that is a easy way. So that is the first condition: when object placed between pole and focus. Okay, this is what we have studied in mirror. Now coming to the lens, I will explain about the lens. Okay, first you listen carefully. I have drawn the structure of lens. Okay, this is a biconvex lens. Bi means two sides. Two. Both sides are bulged. At the midpoint, in mirror what we have studied, this is a concave mirror, and the midpoint on the surface of the mirror is known as pole. Right? But here it is called optic center. We can denote with letter P, or for easy understanding you can use the letter O. So O is called as the midpoint, exactly. O is called as the optic center. Optic center. So why we are calling optic? Optic means the study of light. It's called as optics. So here we are studying about light chapter. So the name is given optics or optic center. It is called as optic center. So when you draw a straight line passes through pole in mirror, that is called principal axis. Same way here also, even for lenses, a straight line, an imaginary line which is passing through optic center is called as principal axis here also. Okay, fine. Now listen, there is one more important point you should remember. You should learn that actually. See, in mirrors, actually concave mirror or convex mirror, they both are spherical mirrors. They are a part of spherical mirrors. Okay. Suppose if this is the structure of concave mirror, if I extend, what is happening here? If I extend it, I will get a circle, right? A sphere. So this midpoint is called center of curvature, and this point pole, and between pole and F, pole and C, we have focus point F. We denote with letter capital F. Okay. So how many center of curvature are we getting? One. How many focus point? One. Because only one cycle. Now come to this lens. Here, how many possibilities, that how many spheres that I can make using the lens? I can make two. I will show you. See here, this structure, this right side bulged part, if I extend, I will get one sphere left side. If I extend, I will get another sphere towards right side. Understood? So then, if for one sphere we have one center of curvature, one focus point, here two surfaces or two spheres we are getting, so we get two focus points and two center of curvatures. Okay. So now optic center O, or we can also call it as denoted letter P, optic center. Okay, P, and here F, I will locate a midpoint. F1 focus, we get two focus points, I told you. So I will denote it with the letter F1 and another point C1, center of curvature. Or in textbooks, it will be given like this: F1 or 2F1, both are same. 2F1, C1, both are same. Okay, don't get confused. Okay, alright. Now P optic center, and here F2 second focus point, and another at same distance. To get the ray diagrams, I'll explain you. Okay, how to take the measurements, or to get the clear ray diagrams. And F1, F2, C1, C2. Or in textbook it will be given like 2F2, both are same. 2F2 or C2, both are same. Why we got F1 and F2? Have you understood now? Because two sphericals or two spheres that we are getting when we extend the two curved surfaces. This is the reason. Okay. Now I hope you have understood between the lens and mirror. Okay. Just to compare, just concave mirror, convex lens, ray diagrams. Okay. So this is called the midpoint, optic center, focus point, center of curvature, focus point second, and center of curvature. F2 or 2F2 or C2, both are same. F1, C1 or F1 to F1, both are same. Okay. Now, so one more point you should remember. Suppose if I don't want to use this type of this symbol, as I have already told you, you can use this symbol also. Very simple. Okay, so same again, exactly the midpoint, optic center, principal axis. Locate here one point, same distance, F1, and again same distance, equal distance, here also equal distance, C1 R 2F1, right side C2, sorry F2 and C2 R2F2. Okay, one more point you should remember. See, here I have considered this left side as a first sphere and this as a second. It's not mandatory that I should take F1 left side, I should take F2 only right side. No, even you can consider this as F1, this one also F2. No, here you can consider it as C1, C2. Both are same. So that's it will change. Here you will get 2F2, you will get 2F1. Understood? Okay. So very easy. So these are the two different ways which we can draw the ray diagrams for lenses, convex lens. Okay, fine. Now, so let us go for drawing the ray diagrams. We will learn now. Okay, another important point I will tell you, in the board exam, it can be asked for even in MCQs or for 1 mark. Okay, the first one, see convex lens, the convex lens, okay, and this is concave lens. These are the structures. Okay, here optic center and exactly optic center for this. And this is the principal axis for convex lens and principal axis for biconcave lens. Suppose if I use the symbol, so this will be the structure. If I use the symbol for this, this will be the structure. Okay, fine. When a light ray passes parallel, okay, when a light ray passes parallel to the principal axis, see, okay, parallel to the principal axis. One more point you should remember. Many of the students will do mistakes here. Some students will draw like this, straight line. Some students will extend the straight line inside the lens. That is wrong, because here light rays are coming from air to lens. Air to lens. Lens is a transparent material, it's a glass. So what happens here? The medium is changing. Here air is less denser than lens. So density of lens is more. So what happens when a light ray enters into more denser medium, it will bend and travel. That also I will make one more video about refraction. Okay, reflection I have explained. Always study in this video only. Okay, so what happens? Light ray has to bend. But what few students will do, they will extend the light inside the lens. That is wrong. You should not extend the line up to here. You should stop the line exactly on the surface of the lens. So what happens when the light ray enters into the lens? It will refract. It will bend. Actually, it will bend here, bending again from here to here. Again, it will bend and travel. Understood? Because the medium is changed. And here, bend, and again it will bend and travel. So this is how the light ray travels when it passes through biconvex lens. Okay, so now let us consider or imagine for mirrors. Think, compare with mirrors F, center of curvature, right? So what was the first rule when a light ray passes parallel to the principal axis? After reflection, what happens? It passes through focus point. Similarly here also, light rays are traveling parallel to the principal axis after refraction. After refraction, it passes through focus point. Okay, if you are taking F1 here, C1, then it will be F2 and C2. I hope you understood. So what is happening? The light rays are meeting. They are getting meet at a focus point. This is meeting is known as converge or converging. What is converging there? Light rays. Okay, so that is the reason convex lens is also known as converging lens. Okay, converge means light rays will meet when they pass through it. Now come to this concave lens. Okay, so this is about mirror, concave mirror. Now here, convex mirror, pole, okay, focus point and center of curvature. So when a light ray passes parallel to principal axis, when it falls on the surface of convex mirror, what happens? We have seen that the light ray have moved away, diverge. Okay, if you extend, it it appears to pass through focus point. Understood? Similarly, here also, what happened is, I'll draw the diagram. Okay, you may note of these points. When light ray travels parallel, here also same. Here, even see, I have told you two surfaces. Even for biconcave lens also, how many spheres we are getting on both sides? Two, right? So F1 again, F1 C1, F2 C2. Clear? Okay. Right. So what is the condition when the light ray here in convex mirror? In convex mirror, what has happened? Convex mirror, when light ray pass parallel, after reflection it diverges away. It appears to pass through focus, not actually appears to pass through focus point. Now here also same. What happens when the light ray strike the surface of the lens? It will bend and travel. Okay, so it will bend, and what happens is it will diverge or move away in this like this. So they have move away, and here what is happening? It also move away from the mirror and appears to pass through focus. Appears dotted lines. Here also what you do is just you extend these refracted light rays, and they will meet at point, and that point is focus point. I hope you understood. So that is the reason. What is happening when light rays are entering through concave lens? They are moving away. It's called diverge. That is why biconcave lens are also known as diverging lens. Clear? Understood? I hope you have understood it very easy. So convex lens are also known as converging lens. Concave lens are also known as diverging lens. Okay, this is about the lens. Okay, fine. Now coming to the ray diagrams for lens. Before drawing the ray diagram, you should know the rules. Okay, there are three rules I will tell you. The first one, rule 1. Okay, rule 2, you should remember, then only it is easy. And rule 3. Like rule in mirrors. So what are the rules? What are the rules? Pole, focus point, center of curvature. If a light ray travels parallel to the principal axis, after reflection it passes through focus. Now same rule 1 for lens. I'll just draw here. Okay, I hope you can see. Optic center, focus point, center of curvature. So what is happening? Parallel for concave mirror, convex lens. I will also draw parallel. So after reflection here, it is refraction. What happens after refraction? It passes through focus point. Understood? Compare? Okay, fine. This is the first rule. So when a light ray passes parallel to the principal axis, this is the principal axis, after refraction it passes through focus point. Here also same. Rule 2 for concave mirror. I am talking about lens, just I am comparing both the diagrams. Okay, so pole, focus point and center of curvature. If a light ray passes through focus point, after falling, after reflection, it passes parallel to the principal axis. Similarly here also, convex lens, okay, convex lens, optic center, focus point, center of curvature, focus point, center of curvature. So what I do? Focus. So now draw the light ray is passing through focus point. So what happened? After refraction, it passes parallel to the principal axis. Understood? So after refraction, it passes parallel to the principal axis. This is the second rule that you should remember. Now rule 3. Third rule. Pole, focus point and center of curvature. If a light ray passes through center of curvature, after reflection it passes in the same direction. Now same thing for here, for convex lens, optic center, F1, C1, F2, C1. So if a light ray passes through optic center, It will not deviate, it travels straight. That is the one point you should remember. What is happening? When a light ray passes through optic center, after refraction also it travels straight. Okay, so these are the rules that you should remember before drawing the ray diagrams. Okay, so rule 1, parallel after refraction focus point after refraction parallel, optic center travel straight. Okay, these are the 3 rules you should remember to draw the ray diagrams. Now one more point I will tell you. There are few cases, refraction, I told you refraction. Okay, let us study about refraction. So what happens in case of refraction of light when a light ray travels from one medium to another medium? It bends and travels. Imagine that I have considered the surface. This is the surface of between two mediums. One is air, above the line air, and below the line it is water. Okay, so we know that water is more denser than air. Air is less denser than water. Okay, so consider that the light ray is passing, incident ray is passing from air to water. When it falls on the surface of the mirror, surface of the water, what happens? It bends and travels. It will not travel straight. Why? Because the medium is changed. This is the first case, and this is called incident ray, and this is refracted ray, not reflected, it is refracted ray. And this is called the midpoint, as you know that point of incidence, similar to mirrors. And if you draw a perpendicular line, straight line between incident ray, refracted and point of incidence, that is called normal line, and the angle is angle I, angle of incidence, and here angle of refraction, letter R. This is the first case. Second case, suppose just consider if the light ray is passing from water to air. Okay, water to air. Just you consider the water to air. So in this case, what is happening? When light ray travel from rarer medium, rarer consider as air, and water consider as denser. So when a light ray travels from rarer to denser medium, after refraction, it travels, the light ray travels towards the normal, Okay, so what is happening? The direction is changed. In this case, direction changed. Actually, the actual direction is, this is the actual direction. This is the actual direction, but direction is changed. Bending and traveling. And what happened to the speed? Speed also changes. And it travels closer to the normal. Now coming to the second condition. Water. Now water is denser and air is rarer medium. So here what happens? When a light ray travels from denser to rarer, after refraction, it travels away from the normal line. So here this is angle of incidence and angle of refraction. Here angle of incidence is greater than angle of refraction. In this condition, angle of incidence is less than angle of refraction. So what is happening when light ray travels from denser to rarer medium? After refraction, light ray travels away from the normal line. This is the second case. Okay, let us consider the third case, case 3. Okay, please note down. Again, same medium, water and air above surface. If I pass a light ray, an incident ray perpendicularly, exactly perpendicular to the surface, what happens after refraction? Also, it travels straight. After refraction, it travels straight. So, and where is the normal line? This itself is a normal line, considered as a normal line. So, when here I am not making 90 degrees, it is not making 90 degrees with the surface. Here it is making 90 degrees with the surface. Okay, so when a light ray passes 90 degrees perpendicularly to the surface, even the medium changes, but it travels straight only. It travels perpendicularly even after refraction. These are the 3 cases which are very important that you should remember for refraction of light. Okay, and one more point, the speed of light. The speed of light is 3 into 10 to the power of 8 meter per second in vacuum or air. Okay, this is also one important point that you should remember. Speed of light in vacuum or speed of light in air, 3 into 10 to the power of 8 meter per second. Okay, fine. Now let us learn about the mirrors. Okay, mirrors. So lenses. Concave mirror, I'll just compare both concave and convex. Okay. So concave mirror, what we did is concave mirror. I'll compare both, and then it will be very easy to understand and learn. The first case, pole, focus point, center of curvature. So what is the first case? Here, first I will place the object between pole and focus point. So where is the image formed? Image formed when light ray passes center of curvature after reflection, also it passes. So here we got the virtual image in this case. Okay, so already I made a video. This is how we got. So when object is placed between pole and focus point, we are getting the virtual image and behind the mirror. Now come to the lens. Okay, lens. Here f1 and c1, f2 and c2. So what you do is, whenever you are drawing the ray diagrams, first you use the pencil scale, draw the lens structure, locate the midpoint, optic center, draw a straight line, principal axis, and measure the distance with scale. From P to F, suppose imagine you are taking 3 centimeter. Same way from here to here also you take 3 centimeter only. If you are taking it 5, here you should take 5 centimeter. Then only you will get the clear, clear images or the perfect images. From P to F2, if you are taking 3 centimeter, if you are taking 3 here, take 3 centimeter even right side also. Same way. Okay, now you just compare between pole and focus. Now here between optic center and focus point. So what I'll do, I'll place a object. What's the first rule? I have explained already. Parallel. Parallel. So what happened? Refraction. After refraction, it passes through focus point. Okay, it should be straight actually. Focus point. Clear? Now, what is another rule? There are another rule is through focus point or optic center. So through focus point it is not possible. So what I will do is I will pass the light ray through optic center. Okay. So optic center, what happens? It should not deviate. Okay. Straight. Now see here in this side, same way here also the light rays are moving away. Here they are moving away, so there is no chance to meet. But at this point, if you see at this side, they are coming closer, so they have a chance to meet at some point. That is the reason we have extended, and where both the light rays met, there we have drawn the image, virtual image. Same way here also, extend here both the light rays. Okay, if you use the scale, then you will get the exact correct images. Okay. Here both the light rays met at this point, and here it will be the image. So where is the image formed? Image formed on the same side of the object. Object is this side, image also the same side. So this is the first rule. Here we are behind same this side, here also. So what are the characters we have written? Nature, image is virtual. And what about this one? Here also virtual image. And how the image is magnified, image is enlarged, big image. Here also it is a enlarged image. And how it is straight we call it as erect. In the same way here also erect. And where is the image formed? Image formed on the same side. Image formed on the same side. Image formed. Image is virtual. Image is erect. Image is enlarged. Image formed on same side of on the same side of the object. I hope you have understood, right? Just compare. Same, both are look same. Okay, so concave mirror, convex lens. Okay, now let us study about the second diagram. Okay, so what I told you first between, then after what is the next place we have focus point. Here also first you have placed between optic center and focus point. Now again move the object. Where is the next point we have F1. Okay, I'll draw. Practice, you need to practice more. Second one, when object placed on F and here on F1. Okay, when object placed on F1 in front of the convex lens, in front of the concave mirror. Okay, so re-diagram. Concave mirror, pole, focus point, center of curvature. If you place object on focus point, two conditions again: parallel after reflection passes through focus point. Okay, another condition, take through center of curvature. Okay, if you use the scale, if you draw properly, you will get a parallel lines. And we know that parallel lines will never meet. So both are parallel. So is there any form? Where will the image form? Image will form at infinity. Okay. So here the light rays are not meeting. So we consider it as the image formed at infinity. Now come to this convex lens. Compare again. Okay, convex lens, optic center, principal axis, F1, C1, F2, C2. Okay, so where is the object? At here, F1. Understood? Okay, F1. Then, okay, parallel after reflection passes through focus point. And another condition, take through optic center. Okay, so what is happening again? We got the parallel lines. Even if you extend this side, here parallel, here also you get parallel lines. Do you understand? Okay, so where is the image formed? Image formed at infinity. And how the image will be magnified. Okay, highly magnified. That way, these are the nature characteristics for the image formed. Okay, for convex lens. Okay, both are similar. Now F completed. What is the next position between F and C? Here also F completed. Next position between F1 and C1. Okay, that is a third condition for ray diagrams. Okay, third one, when object placed on. Okay, F completed between F and C. Here also object placed between F1 and C1. Clear? Okay, now draw the diagram. I draw the diagram here. This is the concave mirror, pole, focus point, center of curvature. So where is the object placed between F and C? Parallel passes through focus point. Okay, another light ray, focus point passes parallel. So where do we get the image? We get the image beyond C. And you see image formed beyond C, and it is reverse. We use the term inverted, and how it looks like big. So enlarged and right side of the mirror. So it is a real image. Understood? Okay, similarly for convex lens, optic center, F1, C1, F2 and C2. Okay, where is the object is placed between F1 and C1. So I will take a parallel line. Okay, light ray parallel passes through focus point. Okay, so here I don't have a space, and take light ray from optic center. Okay, if you extend, they will extend and they meet at a point. Okay, just consider here. So here the image is formed. If you scale properly, if you draw, then you will get the lines met beyond C. Same here, what beyond C? Here beyond, image formed beyond C2. Okay, and what image is real or virtual? It is a real image, and image is inverted, and it is bigger in size, so we call it as a image is enlarged. Okay, compare both the same, concave mirror and convex. This is another condition. See, it's not like that. You should use only this symbols, this structure. Even if you use this structure also, you will get the same. Okay, I'll just draw. You can draw in this way. No problem. So F1, C1, F2, C2. Okay. So where is the object placed? Here. And light ray passing parallel, passes through focus point, next through optic center. It will not deviate. It travels straight, and it will meet at this point and this point. So beyond C, where the image is formed. Understood? Both are same. You can use this structure or this structure. Both are same. Fine. So now between is completed. After that, next position is C. Pole, focus point, center of curvature. Place the object on C, parallel, passes through focus point, take through focus, and you will get the image exactly. Image you will get here only on C. Okay, so image also will be formed on C and C, and same size. Image is of same size, and it is a real image. It is inverted, and image formed on C. Okay, if you use the scale properly, if you draw, you will get the structure perfect. And same pole F1, C1, F2, C2. Okay, so where is the object? C1. Draw the line parallel. After reflection, what happens? It passes through focus point. Okay. See, suppose if I try to draw through optic center, just for your understanding, there are rules. You can try. If you are trying to draw through F2, it is not meeting on C. Okay, through pole, it is not actually meeting on C. So what I'll do? I'll use another rule. Okay. So I'll take passing through F. So F, what happens after refraction? If it is passing parallel, focus point, through focus, parallel. Okay. So what you'll do is, you can draw in this way. So here you will get the image of this object. So image also same way on C1, C2. So image form on C2, and how it is? Image is inverted, and what is the size? Same size. And is it real? Yes, it is real image. Clear? So compare both. Same size, real, inverted, formed on C, formed on center of curvature. Clear? Okay. Now C is completed. Next, beyond you will get between F and C. Okay. This is the last diagram using convex lens. Okay, I'll draw object placed beyond C, pole, focus point, center of curvature. So beyond C, parallel line. Okay. point C, take parallel, focus point, and parallel. So where we are getting the image found between F and image is found between F and C, and it is real inverted. Okay, and how it looks like? It is a smaller image is smaller than object, so diminished. We write that image is diminished, and real inverted found between F and C. Image is found where? Between F and C. Same, compare, draw for the lens also. Convex lens. Okay. Here you place an object, draw a straight line. Lens, I'll increase the size. Okay. So parallel after refraction passes through focus point. Okay. Now you can take again focus, refraction. Where it will meet? It will meet here between F2 and C2. So here between F and C. So image found where? Image found between F2 and C2, and image is here real. Here is also real image, and it looks reverse, inverted, and smaller in size. Object is bigger in size, image is smaller in size. So we write it as diminished image. Okay, understood. So these are the ray diagrams, maximum 6 ray diagrams which will be asked in the exam. So very simple, just you compare concave mirror, convex lens. And what about convex mirror? Wherever you place the object, image will be found between pole and focus only. So you will get smaller image, okay, smaller image, virtual and erect. Even you get only one diagram or one condition when object is placed in front of biconcave lens. So where do you get? You also get the same point between P and F. So that is a ray diagram for biconcave lens. Okay, I will draw the diagram here. Convex mirror and biconcave lens. Okay, convex mirror. Focus center of curvature. If you place object here, take parallel, what happens? Convex mirror is a convex mirror. Okay, concave mirror completed and convex lens is also over. Now, so what happens? Parallel, it appears to pass through focus. Okay, it appears to pass through focus point. I locate focus here. Okay, focus point. Optic. Okay, this is the one case. And suppose the center of curvature. Okay, I'll take a small lens. Okay, no problem. Parallel, what happens? It passes, it diverge, it appears to pass through focus point. Okay, so another condition you can take, passing through pole. So again it will diverge in this way. You just extend. So where are you getting image? Image is found here. Where? Between pole and focus point. And how the image look? It is a erect means straight, virtual image, and it is diminished. And image is formed between pole and focus. Wherever you keep, you place the object, image will be formed at this point only. That is the reason why we use convex mirror as a rear view mirror, because wherever the object distance lies, image will be formed between pole and focus point, and it looks smaller in size, it looks straight, it don't look reverse. Okay, that is the reason we use convex mirror for side mirrors of automobiles. Okay, and also in the letter ambulance, if you see in ambulance, the letter will not be reversed like this, it will be written reverse, because when we see in the mirror it looks properly or in a correct way, so that we can understand that ambulance is behind us and we give a space for the ambulance to pass. Okay, this is about convex mirror. Okay, let us draw the ray diagram for biconcave lens also. Okay, so convex mirror is done. Now concave lens. So again, lens rule for convex lens I have explained you already. Same way, even for rule one or case one. So biconcave lens, this is the structure. The structure of biconcave lens, optic center. Okay, the optic center, and then F1, C1. Okay. When a light ray passes parallel to the principal axis, what happens in convex lens? It passes through focus point. Now here what happens when a light ray travels parallel to principal axis, after refraction, it appears to pass through focus point, moving away, diverge. Okay, understood? This is the first rule, first condition. Okay, but there it will converge. Convex. That is the reason convex lens is also known as converging lens. It is diverging lens. Now, second rule. If a light ray passes through focus point, after refraction, it will travel parallel to the principal axis, divergent, parallel. Okay. Now, third rule, third rule.